we have to do here. So far, everything we talked about has been two-dimensional. When we talk about three-dimensional, specifically the length of diagonal objects in the real world, such as if I wanted to know what's the largest flagpole I could fit in a box, that's a diagonal problem. When presented with a diagonal, which is a hypotenuse in the third dimension, there's a long, hard way to do this, where you have to use the Pythagorean theorem 2 times and try to find all these different measures. And then there's an easy way to do it. Let me show you the easy. Hard way would be to do this. Watch, but don't write, just pay attention. Here's the hard way. You're trying to find the length of A. So to do that, you'd have to realize that this is 6, this is 3, find the length of this hypotenuse. Once you know this, then you know that this is 4, and you can find the length of that hypotenuse. So you're doing 2 problems. However, I don't need to do this. When you're presented with a 3D object like this, and you're being asked to find the diagonal, here's how easy it gets. You have 3 measures here, right? 4, 3, and 6. It's called square, add, root, in that order. You take the values, 4, 3, and 6, you square them all. 4, 3, and 6, you square them. 4 squared is 16, 3 squared is 9, 6 squared is 36. You're with me so far? Now you guys can start writing. Once you do that, you add them together. And that's going to give you 61. So remember the process. Square, add, root. We take the 3 values. Remember, this is only for 3-dimensional objects, where we're looking for the length of a diagonal. If it's 2-dimensional, like a right triangle, then we just use the old Pythagorean theorem. Here, 3-dimensional object, diagonals, we take the 3 values, 4, 3, and 6, we square them all, and we add them together. That's going to give me 61. So I've done 2 things. I've squared them, I add them, what's the last word? Root. Root. I take the square root of 61, that's going to give me 7.810 ... The reason for the 3 dots is because what type of number is this? It's an irrational number. It is a non-perfect square. Good job. So not only in this lesson are you proving, that's it. If you had done it this way, this is 3 and this is 6 and found this, and then gone and found this, you would have gotten the exact same answer. I prefer this way because it saves you a lot of time.
Yeah, we're smarter now.
You all know how to use the Pythagorean theorem. For this, a little shortcut. Copyright about me. All right. So we take them, we square them, we add them, we take the root. As easy as this is, people do make mistakes on it because they start creating equations out of it. You don't need to. If you're dealing with a diagonal, look at the problem. Is this a 3D object? Yes. Diagonal, red flag, square, add, root. That's all it is. That's all it is. It is known as square, add, root. Very simple. Let's try another one here. Let's see if you guys understand what we're doing. So a box is used for shipping volleyball set. It measures 10 by 20 by 40. What is the longest length of a support pole that will fit into the box? Notice we're trying to find the length of the diagonal support pole. So we have 3 values, right? 10, 20, and 40. And we go through the process. We take all 3 values and what do we do with them? We square them. It goes in that order. Square. You square the values. 10 squared, 20 squared, 40 squared. Once you square them all, you're going to add. Square, add, root. 100 plus 400 plus 1600. How'd you get 100? 10 squared is 100. 20 squared, 400. 40 squared, 1600. Square them, you add them, you get 2100. Yes, Dante?
Okay, I don't want it. So what if we added it first and then squared our
Don't
answer?
do that. Nope.
Okay.
It's got to go in this order. Square, add, root. You do any one of those steps wrong, as simple as they are, it's wrong. Okay? It's square them first, then you add them, then you're going to take the root here of what number? 2,100. You take the root of the number, and you get 45.825 ... Why? What type of number is this? It's an irrational number because this is a non-perfect square. We use the 3 dots to show you that it is irrational. It goes on forever and ever without terminating or repeating. So, questions on this? Questions? Keep in mind this is known as square, add, root. If you can remember those 3 things, whenever you see any one of these problems, super Easy. These are the problems most people get wrong on the essay because they don't know the shortcut. Only seen here on Math Matters Everywhere YouTube channel, brought to you in part by the Marshmallow. Don't forget to like the videos, leave a comment, share it with your friends, and of course, subscribe.